Good day. Now we will see how to solve the problem of line clipping using Cohen-Sutherland line clipping algorithm. Cohen-Sutherland line clipping algorithm is one of the earliest algorithms to be developed for fast line clipping. Processing time is reduced in this algorithm by performing more tests before proceeding to intersection calculations. So what is Cohen-Sutherland line clipping algorithm? We already know that in Cohen-Sutherland line clipping algorithm, the clipping window boundaries are extended so that we are able to divide this entire space into 9 different regions. Now, each of these regions is given a code that is called as the outcode or region code. This code consists of 4 bits, bit 1 corresponding to the left boundary, bit 2 corresponding to the right boundary, bit 3 corresponding to the bottom boundary, and bit 4 corresponding to the top boundary. Okay. So if you take this code 1010, that means any point lying in this region will have the code 1010. Okay. So since this point is not to the left of the left boundary, this bit 4 is 0. Since this point is to the right of the right boundary, bit 2 is 1. Since this point is not below the bottom boundary, this bit 3 is 0. And since the point is above the top boundary, the bit 4 is 1. Okay. Likewise, this points in this region have the code 1000. Points in this region have the code 1001. Points in this region have the code 0001. Points in this region have the code 0101. In this region 0100. In this region 0110. In this region 0010, and inside the clipping window all the points will have 0000. Another way of defining the same thing with respect to the coordinates of this clipping window. The clipping window is defined by xw min, yw min, xw max, yw max. Okay, so bit 1, which corresponds to the left boundary, can also be set to 1 if x is less than xw min, that is this region. Bit 2 is set to 1 if x is greater than xw max, that is to the right of the right boundary. Similarly, bit 3 is set to 1 if y is less than yw min, that is below the bottom boundary, and bit 4 is set to 1 if y is greater than yw max, that is above the top boundary. Okay, that is the second way of describing these bits. Okay, the third way and the most efficient way is by taking the difference between the coordinates. You can, to set bit 1 to 1, you take the sign of xw min minus x. If the sign of this value is 1, that is, if this value is positive, then bit 1 is set to 1, otherwise it is set to 0. Same way, bit 2 is set to 1 if the sign of x minus xw max is positive, otherwise it is set to 0. Bit 3 is set to 1 if the sign of yw min minus y is positive, else it is set to 0. And bit 4 is set to 1 if the sign of y minus yw max is positive, else it is set to 0. What is Cohen-Sutherland line clipping algorithm? Let us brush through it fast. So, if the points x1, y1. Suppose the two endpoints of the line are x1, y1 and x2, y2. You calculate the outcodes for the 2 points. Say O1 is the outcode x1 of x1, y1 and O2 is the outcode of x2, y2. Okay. So first, what is done in the algorithm is you check if O1 is equal to O2 equal to 0, 0, 0, 0. If both the endpoints are inside the clipping window, then O1 and O2 will be 0, 0, 0, 0. That is, the line is entirely visible. Okay. If you take the bitwise and otherwise, if you take the bitwise and of O1 and O2 and the value is not 0, then the line falls outside a particular boundary, and so the line will not be visible, or in the display window you are not going to show that line. The third condition is if O1 and O2, that is a bitwise and, results in a 0, then you cannot immediately decide whether the line is inside or outside. You have to first shorten the line. That is, you will have to clip the line, that is, eliminate a part of the line. Okay, for this, you have to find the point of intersection with the edge of the window or the window boundary. This can be done using the calculations as follows. If the line segment is from x0, y0 to x and y end, then the y coordinate will be given by y0 plus m into x minus x0. If you know the x coordinate, you can calculate the value of the y coordinate by formula 1. Y equal to y0 plus m into x minus x0, where m is the slope of the line. Slope of the line is given by difference in y coordinates divided by difference in x coordinates. Okay, so the slope of the line m equal to y end minus y0 divided by xn minus x0. And substituting this value of m in equation 1, we can, and rearranging equation 1, we can get x equal to x0 plus y minus y0 by m. Yeah, going to solve this problem. Clip the line boundary. Clip the line with coordinates x0, y0 equal to 60, 20, x1, y1 equal to 80, 120, given the window boundaries xw min, YW min as 50, 50, and XW max, YW max as 100, 100. So what is it that we have to calculate first? First, we have to calculate the outcodes for X0, Y0 and X1, Y1 with respect to this window that is defined. Okay, how do we calculate these? By you calculating the 4 bits, bit 1, bit 2, bit 3, and bit 4. Okay, bit 4 is defined as sine of y minus YW max. Now here, YW max equal to 100. So it is sine of y minus 100. Bit 3 is given by sine of YW min minus y. That is sine of, here YW min is 50. So it is sine of 50 minus y. Bit 2 is given by sine of x minus XW max. XW max is 100. So it is sine of x minus 100. And bit 1 is given by sine of XW min minus x. So that is equal to sine of XW min is again 50. So bit 1 is the sine of 50 minus x. So the code at P0 6020 is given by 0100. Okay. Bit 4 is sine of y minus 100. Here y is 50. So sine of 20 minus 100. Y is 20. So sine of 20 minus 100 minus 80 is negative, and so it is 0. So bit 4 is 0. Now bit 3 is given by sine of 50 minus y. Okay, so it is 50 minus 20, that is 30 positive, and so bit 3 is 1. Bit 2 is given by sine of x minus 100. X is 60. 60 minus 100 is minus 40, negative, and so it is 0. And bit 1 is given by sine of xw min minus x, that is sine of 50 minus 60 minus 10, negative, and so it is 0. So the code at P0, that is 6020, is 0100. Next, the code at P1, it is 8120. Okay, so again bit 4 is sine of y minus 100, that is 80 minus 100, negative, so it is 1. Sine of 50 minus y, that is 50 minus 120, is negative, and so it is 0. Sine of x minus 100, x is 80, 80 minus 100 is minus 20, negative, and so it is 0. And again bit 1 is sine of 50 minus 80, negative, and so it is 0. So code at P1 is 1000. Next, we calculate the slope of the line. M equal to y1 minus y0 by x1 minus x0. That is 120 minus 20 by 80 minus 60. That is equal to 5. Okay. Next, we get the equation for the calculation of y equal to y0 plus m into x minus x0. That is equal to y0 is 20 and x0 is 60. So you get y equal to 20 plus 5 into x minus 60. Now x is given by x0 plus y minus y0 by n, and that is equal to 60 plus y minus 20 by 5. So we fill in the values in this table. Line endpoint codes, that is the out codes at the two endpoints, whether we accept the line, the logical AND of the two endcodes, and the decision to be taken. So first the line is P0, P1. We have already calculated the code at P0 as 0100 and the code at P1 as 1000. Okay. Now, since both the outcodes are not all zeros, we cannot accept the line. So we cannot accept the line. Further calculations are required. We take the logical AND of 0100 and 1000. Okay. And the logical AND is 0000. Okay. Since it is all zeros, we have to find the point of intersection. Now this is the clipping window that we have. These are the two equations. Okay. Now which intersection point do we take? We take the outcode of P0. Here we see that bit 4 is 0. We take bit 3 is 1. Since bit 3 is 1 and bit 3 corresponds to the lower boundary, this line, we take the point of intersection with respect to this line. The equation to this line, that is the lower boundary, that is a line parallel to x-axis. So this is given by y equal to 50. Okay. So we have the value y equal to 50. We calculate the value of x. Okay. The value of x is given by x is equal to 60 plus y minus 20 by 5. So that is y equal to 50. We calculate the value of x, and that is gives you the value of x as 66. So your P0 dash is 66, 50. That is the point of intersection is 66, 50. So now instead of the line P0, P1, we will have to consider the line P0 dash P1. That is, the line from P0 to P0 dash is eliminated or clipped off. So now the line being considered is P0 dash P1. Okay, now P0 dash, the coordinates are 66, 50. We calculate its outcode. Again, sine of y minus 100, 50 minus 100 is minus 50 negative, so it is 0. Now sine of 50 minus y, 50 minus 50 is 0, so again it is 0. Sine of x minus 100, 66 minus 100 is negative, so again it is 0. And bit 1 is 50 minus x, 50 minus 66 is again negative, so it is 0. So the outcode of the point P0 dash is 0, 0, 0, 0. We already know that the outcode of the point P1 is 1, 0, 0, 0. Since both the outcodes are not all zeros, again we cannot accept the line. Further calculation is required. We take the logical AND. Again, the logical AND is 0, 0, 0, 0. Okay. So we have to find a point of intersection. Okay. Now we see that for P0 dash, the outcode is 0, 0, 0, 0. Since no ones are there, we turn to P1. For P1, bit 4 is 1. Bit 4 corresponds to the top boundary. That is the equation y equal to 100. So again, I substitute in this equation to x the value of y as 100 and calculate the x coordinate. So y is equal to 100. X is, when I calculate, I get the value as 76, or my P1 dash is 7600. Okay. So now the line from P1 to P1 dash is clipped off, and I get only the line from P0 dash to P1 dash. Next, I have to calculate, I have to write the outcodes for P0 dash, which already I know as 0, 0, 0, 0. I have to calculate the outcode for P1 dash. Okay, that is 7600. The bit 4 is sine of y minus yw max. That is sine of 100 minus 100, and so it is 0. Bit 3 is sine of yw min, sine of 50 minus y. That is 50 minus 76 negative, and so it is 0. Bit 2 is sine of x minus 100. That is 76 minus 100 negative, and so that is also 0. Bit 1 is sine of 50 minus 76. That is also negative, and so it is 0. Okay. So the outcode for P1 dash is 0, 0, 0, 0. Now, since both the outcodes for P0 dash and P1 dash are 0, 0, 0, 0, the line is totally visible inside the clipping window from P0 dash to P1 dash. That is from 6650 to 7600. So the line from 6650 to 7600 is visible and will be displayed in the display window. What are the advantages of Cohen-Sutherland line clipping algorithm? Okay, we have, as we have seen, all the operations are very simple. Okay, next, it is very efficient, especially when most segments don't cross the clipping window. Thirdly, this algorithm can be extended to 3 dimensions. What are the disadvantages? We have recursive division of lines, as the computation of intersections is done early. Next, the vertical and horizontal lines are special cases which have to be treated separately. The edges require special handling with floating point arithmetic. So, in brief, the Cohen-Sutherland line clipping algorithm. First, we calculate the outcodes of the 2 points x1, y1 and x2, y2. Say they are O1 and O2. On the basis of these outputs, we take the further decisions. If both O1 and O2 are 0, then the entire line from X1, Y1 to X2, Y2 falls within the clipping window. Okay, and that is to be drawn. If the bitwise AND of O1 and O2 is not equal to 0, that means the line falls outside that particular boundary where the bit is 1. And so, since the line is totally outside, the line will be rejected and nothing will be drawn in the display window. Now, if O1 and O2, that is bitwise AND, is equal to 0, then we cannot decide whether the entire line is inside, or part of the line is inside or outside. Okay, so we need further calculations that is done. After finding out the point of intersection of the line with the clipping window boundary. So this completes our Cohen-Sutherland line clipping algorithm. Thank you.